Hey, Melody. Should be setting your screen up. That was 5 minute clock for those late people. Me one moment, Mel. I gotta try to help Miss Richardson into the room. Let's see. Send her the invite again. Okay, so that's Ariana. Just send it here. Yeah, her name's here. I like this because I send that send you an invite from inside. The student's like, I can't get in. That's a lie. Yes, you can. Um, let's see here. Let's move this out the way. I'm gonna move this. Okay, so now there we go. And oh, hey, Rush. Okay, Stevenson. Yeah, they're just coming late. That's what I was telling them. All you guys got emails to
Hey,
your account.
hey, Melody.
Huh?
No, it's all Melody.
Oh,
Melody,
camera. Is that what it
turn, turn your, yeah, turn it on.
is? You gotta keep it on, Mel. Okay, thank you, Stevenson, for having your camera on, sir. Everybody wants to be logged into Edsby and also log into your Gmail account so you can do follow along with today's assignment. All right, so let's go to our norms. And here we are. So we start normally with our five basic norms and go through those. So numbers 1 through 5. Mr. Stevenson, can you read that?
Hold on. A matter of fact, I'll do it right quick. But I was finna log into my laptop. Let's see.
Oh,
No
go ahead.
one has the right to hurt another person. Education in the class when I start. We will never behave in a way that will discredit ourselves, our school, and our family. And Access Academy Southwest students always the lady of general. We take pride in Access Academy Southwest.
Thank you, sir. Thank you. Melody Terry, can you read the next five?
I'm about to rejoin right quick.
Okay. I hope he uses the email address.
Can you hear me?
Yeah, I can hear you.
Yeah, we can hear you, but we can't see you.
Oh my gosh.
You gotta turn your camera on, dear. All right, thank you. Keep it on because I was gonna have to make some phone calls. Keep it on for me. Now, can you read the five academic ones here, Mel?
We respect the opinions of others. We respect the culture of the classroom. We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Thank you, Miss Stevens. Miss Terry, I'm sorry. So, Mr. Stevenson, you're back, and are you on your computer now? Are you good? Okay. Uh,
Carry on.
Stevenson, mute yourself, dude. You got a lot of background noise. There you go.
Yeah,
Okay.
and it looked
And
like you're on his computer. Yeah.
he's still setting up. It looks like. Okay, so let's get into our problem. Again, you guys need to have your screen set up so you can follow along, and this won't be hard on you. Go to your class. This is third period. All right, and inside of third period in your EDSB, you will have access to today's assignment. So if you scroll down a little bit, it is pretty much this one here. So we'll grab this, and we're gonna read it out. And I have, let's see here, who's here? Lee Carter's arrived. Okay, welcome to class. Mr. Carter, can you read what's in the chat and put it in there in one moment? And this is for 35 points, by the way.
Hello, all future electrical engineers. Seeking this problems needed to be completed and ready to present tomorrow class. A section of problems need to be completed as homework and will be checked tomorrow in class as well. A gravity system, an enclosed lifeboat on a large ship is deployed by letting it slide down a ramp and then continue in free fall to the water below. Suppose at 4,680 kilograms, lifeboat slide distance of 7 meters on the ramp. That makes the angle 65 degrees.
Okay, thank you. And the rest of it is basically with the vertical, right? So how much work does gravity do on the boat? Right, that's his points. So let's jump into the problem, shall we? Who's attendance? Let me make sure I got everybody who's supposed to be here.
Hey, Lee, something wrong with your camera, Lee?
Yeah, you got to turn that on, dude. Policy. All right, so let me run through the attendance real fast to make sure you guys are logged. So who's here? We're missing a bunch of people. The emails are sent out, so I don't know what they're gonna say this time. um, we got Stevenson. We have I think Ortiz is saying Richardson has to check her email. Carter has arrived. Who else we got here? Melody. All right, okay. Everyone else is absent. Okay, so let's continue on. What we want to do is we want to make sure we go to our Google Doc, open it up. Okay, and you'll get a blank document once you open it. You double click on the blank icon here, and we're going to start a new document. So let's go through it slowly, this problem, right? First, change your document from untitled document to document. You double click in here and just type do now. Everybody's doing what I'm doing. And the date, which is 11th, Veterans Day, yay. 11/2020. Next, you're going to do your header. So that's going to be your name, right? Like I'm typing where my name is. And then, of course, the date again, right? Also, the period is a third period. And this is for intro to engineering with robotics students. All right, so I'm gonna come down here, and now what I want to do is start getting the title, exit slip, and the problems. So I'm moving up the chat for a second, and who can tell me what they think the title of today's assignment is? That is for 15 points if you can put it in the chat. Anybody know? Okay, so nobody knows where to find it. And what you would normally do if you was an SB, which you should be now, you would simply make sure you go to your right period and you scroll in to find the title. So the title is right here. It says do now, gravity escape system. That's the title for today. All right, well, let's put that in our document. And I'm gonna put it in the chat for you guys as well. So you'll have it, so you can put it in your document. Okay, so put that there. Have that. Now let's keep moving on. You put the title here, and let's center this. Zoom in. Do that. And this is going to be centered. Come down, and now we're ready for our exit slip portion, right? So exit slip is basically worth 25 points towards previous assignments. Okay. Now, it is composed of two things: your classroom term and then the word of the day. Okay, and you got to say what those two are. We'll come back to that, but these together with their definitions gives you 25 points, which helps out a lot later. Okay, questions. Let's put the questions in there. So the first question is the one that Lee had just read to us. All right, so I'm gonna come over here and I'm gonna grab the questions. And the thing when you guys are trying to grab things from Etsy, it's better if you just go inside the assignment and then try to copy it. If you try to copy it from the classroom, it's tough. So we'll take these two questions. And remember, we have a synchronous problem and an asynchronous problem. So one of these problems you have to do at home and have all the steps too. Now, asynchronous problems can also be done with me on asynchronous days. For robotics students, that's tomorrow. So I'm probably not going to do too much on what is it called, a substitution method tomorrow to give you guys time to finish up on the second problem and at least get ready for the quiz. So let's go through this problem. These problems, there's two of them, and this is the product you read. So make sure that's in your document. Like, I have both of them. And now we're gonna, just try to solve for what's necessary here. Now the goal here is still the same. Let me make sure I got this correct. So word of the day. Let me pull up my word of the day calendar. There's Richardson. She got the email. I've emailed all you guys. I stayed up last night to make sure this worked. Let's see here. So then, where are we at? We pull up the
Hey,
calendar.
Mr. Tyler.
Hey, Ms. Richardson, I see you. You might want to try to keep up or catch up. We've already started typing up our document. What was I saying? So the November calendar tells me. Anybody know what the word of the day was? I can't remember off the top of my head. Let me see here. Gotta go to the Google Drive. And I'm just giving you guys a little time to catch up and type while I look up the word of the day for you. So from the calendar that Ortiz gave us, it's plausible. So for the 11th, it's plausible. So let me type that in here for you. That's the word of the day. They said it in Townhouse and GGI, I think. Plausible, right? And our term of the day is, I think, distance. I want to say you're using angles. So I'm using the term distance here, and you have to tell me what distance means. Okay, we got that out the way because our objective here is to still use the work calculation. And who remembers what the work calculation was from yesterday? How do we calculate work? Well, if you were in class, you would have remembered, and then you would have gotten at least 25 points. But we'll wait for share outs. I guess you guys are still trying to type it up. So if you don't remember, work is equivalent to the force, right, multiplied by the distance. Okay. So this is pretty much notes from yesterday that I'm putting in. This is going to expand a little bit because we're taking it a step higher in terms of how it's applied. Come down one, and now I got to talk about what each of these is measured in, because I don't know if you remember this part. So work is always measured in joules, right? We'll be beating this into you guys' heads until the quarter's over with. How to get these dimensions right, how to do your notes, all this. So get used to it. And force, if you don't remember, is newtons multiplied by distance, which is always measured in meters. Those are your initial notes. Let's keep going. You also need to understand that there is an angle here. The angle is usually called theta. Now, when you have angles, this is for calculating work. Put this in the center for you guys. This is for calculating the work without angles. And this one that I'm going to give you now is for calculating the work with angles. So, somebody left. Melody left. I hope she's coming back. All right. So with angles. Okay. With angles, because we have an angle in our problem. Angle there is 65 degrees, if you noticed it, right? It says makes an angle of 65 degrees. And that's vertically. So normally I would have you guys draw first, but let's get the notes out and then we'll do our sketches. So what's the first thing we need? Well, you need somewhere to insert the angle. Take this work equation and I'm going to show you how it changes. If you've had trigonometry, welcome back, Mel and Richardson. Oh, yeah, okay. I must have switched devices. So this is going to be extended by cosine and then theta. Theta is written, so we'll put theta is an angle, but I'll explain that. So let's just put the symbol theta first. or theta, as I was taught. Okay, and now I'm going to go select math. What's the special characters, by the way, in case you guys don't know what that is. And then next, I want to type in theta. That's theta. Right, there it is. And put that there. All right, you just got to choose one. So I clicked on it. I think it selected it. And there it is. So it's cosine theta. It's not 0, guys. It's actual math symbol. So make sure you edit the same way. Okay, so now we have that. And theta is, let me write that out too. Theta is spelled theta. And it just simply means the angle you're using. Okay, so that's theta. Now, cosine itself is a trig function. And I'm not sure how much math you guys have had. You did cosine, sine, and things like that. But you need these initial notes, especially for Friday's quiz coming up. All right, so get that typed up. I'm going to start going through the known and unknown values, and you guys are going to have to edit your document the same way. The reason I'm putting it in the chat is because we still have to do a sketch, and then I give you time to get all these notes correct. You see in the chat what I gave you, but make sure you edit the same way. Your notes should be in the center right after the question. Next, we can set up our known and unknowns, right? So known, what do we know about the problem? Unknown. What don't we know? Or what is the problem asking us? Let's start up here. In a gravity system, right, we read that part. It says, suppose a 4,680 kilogram lifeboat slides. Now, kilograms, if you remember from yesterday and the day prior, it means mass. So we're going to put mass is equal to, and that value was, let's come here, it's 4,680 kilograms. Next, we need what? Well, let's see what the problem gave us. But then it says a distance, that's D, right? So distance, let's come over here, usually lowercase d, is I think 7.0, right? And now we need one more value that you may not be aware of, gravity on Earth, because there's one more equation you need here. And that's the basic equation for force of what a Newton is. So force is equal to mass times acceleration. Right? This is why I wanted to get the problems steps out the way, because before we start drawing stuff, we got a lot of stuff to type in here, right? It's 12:43. So let's keep pushing and try to get a lot more done so you guys can get this turned in by 8 tonight. This problem here is the same as this problem. The numbers just changed. So you guys got to do the same steps and set it up correctly, and you'll be okay, and calculate it out. Kind of like a practice problem, if anything else. So I was telling you, force is equal to mass times acceleration. If you don't remember the dimensions, here they are. You can see where these things go. So again, force is always measured in newtons. This tells you how to get newtons if you don't have them, and we don't yet. They gave us the mass, but we can get close to it. So newtons equal to mass, which is in kilograms. Right? And this is times acceleration. And we talked about this a little bit on Monday, but you might have forgotten that part. Not acceleration, but meters per second. Sorry. Okay, so that's the notes for that part, and the equation for it is just simply F is equal to ma. And for the equation of work in this situation, you just simply rewrite it as work, or W, is equal to F times lowercase d, and then you take the cosine theta part and put it there. So here with that. All right, thing of beauty. All right, now we'll put this in put what I have so far in the note in the chat again, in case you might not have noticed what I did there. And what I was telling you about earlier is gravity, which is a form of acceleration. So gravity on Earth, that's lowercase g. If you jump out of a plane or you just jump up and down, something's going to pull you back down. And in some cases in science, they say something's pushing you back down. Depends on how you think about that. So that's measured on Earth is 9.81 meters per second. And with acceleration in squared, so to the power of 2. Okay. So let's come up here. And I want to make sure I put second squared there too. I didn't. All right, I'll put that there. There we go. All right, so we're going to raise this to a power of 2. And we're going to raise this to a power of 2 because they mean the same thing. All right, so far so good. You should have about as much as I have so far because we're going to do share outs and just see if you can keep up with me. All right, so that's gravity on Earth, lowercase g. What is the problem asking us? Well, in the end, it's asking us for the work. But in order to get the work, we need the force. So work, that's an unknown value. It's that W in our equation is equal to some number in joules. I'm going to calculate that in a moment. But before you find that, you need the force, which is going to be the F in that second equation I gave you. And that's going to be measured in newtons. All right. So let's calculate it out. First, let's get our force. So strategy. Solve for the force. F here in newtons. All right, so to do that, we got to use this equation. F equals ma, right? Let's come here. Force is equal to mass times acceleration. Let's put that there. And I'll come over to the side. Okay, so now I'm at the point where I can figure out the force because I have acceleration. If you didn't know, this is also acceleration A. That's just acceleration of Earth. Okay. We have the mass, so we have the acceleration, we have the mass. Let's put it in together and see what happens. So grab this. And let's put the values in. So mass was this big number here, right? 4,680. Here, and put that in there for mass. Acceleration was, we just said what it was on Earth. It's 9.81 meters per second squared. All right, so far so good. It's looking very good. Now, anytime you multiply kilograms on meters per second squared, you automatically get a newton. Close parentheses. So what happens is this two parts cross out and then combine to make a newton. We can cross this part out. And this part crosses out. When your powers combine, I am a newton. Professor Isaac Newton. So a newton shows up after you do that combination. All right, so let's clean this up. And like I said, this is gone, right? And this part is gone, right? So all we gotta do is just calculate it, but we're not done, everybody. Don't think you're done with this. You still gotta go back and calculate, and it's 12:49. We're doing good on time. I don't know if you're gonna have time for the because we still have to do work. So this is going to be calculated with Math Papa, or I think since it's simple enough, we could use Google. So let me remove this. And we got to calculate our new answer. So you're going to use this Math Papa tool. And it's an online calculator that helps you guys in case you don't have a calculator tool. So I'm going to put that in the chat for you. And it is something you can click on and open up so you can calculate your problem for problem 2A, which is your asynchronous homework problem. All right, so with that said, let's plug it in and see what this is going to become. I'm going to say, hey, what is this? 4,680 multiplied by, what was that over there? I think it was 9.81. Hit enter. That yields about, this is 4,000. That's a lot of force, right? So let's put that in there. That's 4,000, 45,000. Is that what it is? 45,910.8. Blah. Okay, so 45,910.8 newtons. All right, so that's not done. We're going to use this to now find our work. So to find our work, we need to remember our equation up here and use the angle. So there's one other known value you didn't put in here. If you didn't notice, where's our angle at? Let's come down one. And this is the theta part. So remember I said there's something called theta. So we're going to use this, which is you write it like this the entire time until you put the number in. So I'm going to put theta right here. And if you want to know how to put theta into the document, go to Format, come down to, I'm sorry, not Format, Insert, Special Characters, and make sure you select the math feature so you can choose theta, which is how it's spelled. That's equal to, if you go to your problem up here, it was 65 degrees. Okay, so 65, and then you're going to put the little degree symbol. So you hit Insert, come down Special Characters, and if you come to Math, make sure to select it. You can put DEG for degree, and there's a degree symbol, right? There we are, and that's how it's supposed to look mathematically. Now that little symbol means degrees, by the way, so don't get confused. But all I did is I went to insert the degree symbol and it's there. All right, now I think we're ready to rock and roll on the next part. Next in our strategy, solve for work at W in our other equation, right? In joules. It's the last step in your calculation. So you come back here, and what do we got? Well, remember, you got to look at this equation here. This is telling you with an angle. If you don't have an angle, and I want you getting confused on this because on Friday you'll have a work problem and there's no angle involved. This is the one you use. If you have a problem with an angle in there, this is the one you use. Okay, just bear that in mind. Don't get confused. So I'm gonna bring this equation down here so we can finish it off. All right, we're gonna bring this over because we're gonna work on it. And it's very straightforward at this point. You can just plug your values in. So looking at this equation, it says what? It says work is equal to, we just put the numbers in. We have them from above. We now know our force. We just found that, right? So we'll grab it from here. Parentheses and put that in there. And then we know our distance, right? It's up in our known values, 7.0 meters. Take that from here. If it lets me. Okay, it did let me. Now, it's the distance here. And we're almost through, y'all. I know you're tired and like, okay, man, is he done yet? Our angle, which is 65 degrees. Right. I'm gonna take that and we'll put that here. Now, some things will cancel and recreate other things. And the final answer will be consisted of what we put next. So we know meters and newtons, when they combine, they make joules. We discussed this on Monday, Tuesday, and I'm saying again today. That's the objective, to understand the work equation. I'm gonna cut this, I'm gonna strike this out. Strike this out because these two, when they multiply together, in physics, it just indicates you have to say that's now joules. So we'll put joules at the end of this. And then we're gonna go down a step and clean the equation up. So I can now get rid of this meters portion, right? I can now get rid of the newtons. And just calculate what I have. So let's do that. We're gonna use Math Papa to do it. And I suggest you do it with me because you have to do this similar problem the same way. And now you got 87 degrees. If you try to use Google Calculator, you might get the wrong answer because you have to.
I'm gonna start the chat, Mr. Tyler.
Yeah, I could put some of it, not all of it though, because I want you guys to do some of it yourself. All right. So give me one moment. I want to do the final calculation. Um, so this part right here, everybody, is going to be typed into Math Papa. This is what you would do. So we retype it. It's 459910. Did I do that right? No, I did not. 45910.8. There we go. Times 7.0 times, and then you just type COS cosine, and then parentheses the angle. So it's 65 degrees. Close parentheses. Hit enter. It should do the trig function for you, and it did. So the final answer in terms of, oh, it's a lot of work, is, I don't even know how to say that. So it's going to be negative, because it's basically going to with gravity, and that's what the cosine or the trig function does. So it's going to be negative 1. Oh, I'm not even over there. I got to type over here. There we go. Taking this value. It will be negative 180,758. And let's see, 2 digits. Neat. So how do we say that number? It's grouped in 3. So that's 180,758.94 joules negative. And that is your final answer for your in-class problem. So we need a moment where you guys share out. You want me to put some things in the chat, I think. So let me do what I can for you guys. But listen, you cannot just copy and paste from the chat. If you do, I'll know, because it will be wrong. There'll be parts that are not crossed out. There'll be things that are raised to a power that are not. It will look horrible. So take your time and do it correctly. Let's start from the top with the first set of notes. So let's see if this fits. Here's your first set of notes. They all made it over there. All right. That's what we started with. For what should be in the center, those are your main notes. All right. Now I'm about to go through the next part. And this is the second section where you're working on your strategy to solve it with the known and unknown values. Okay. Again, take your time and edit it correctly. The chat does not cross things out. I hope you're keeping up, because I'm about to start a timer. This is the last set of notes. So again, you can't just copy and paste it. I'll know. Go through, clean up your document, and then be ready to start tackling the asynchronous problem tonight. All this is due by 8 p.m. Both problems. And the second problem is really the same. It's just different numbers. You got to go through and do the same steps, right? So I'm gonna give you guys, let's see, it's 12:59. We get out of here at 1:20. I can give you guys 10 minutes to work on it, and then we'll be ready for share outs. Okay, I want to see your screens.
C. Miller, and Chairman to the Joint Chiefs of Staff, General.
Mr. Tyler, can I see your dog right quick?
Sure. Just trying to make sure you guys didn't forget about the exit slip. Let me stop that. Okay. You're doing it up for Veterans Day. All right, so I just don't have time to sit down and barbecue or nothing. Is this what you need to see?
Go up. I'm trying to see how you had the known and unknown set up, because in the chat it's kind of mixed up.
Oh, yeah, that's what I was trying to tell y'all. So who is ready to share out? Because it's 109. Anybody? Because this is for your in-class points for everybody. So at this point, this is how I see how much you've gotten done, and I add it to your bank of points you're supposed to be stocking up. So let's go down the list. Ms. Richardson, what do you have so far?
I'm finna share my screen.
Thank you. So screen feature should be activated for you. Should allow you to share now. Having some trouble there, Miss Richardson?
What we doing? We sharing out.
Yeah.
Can somebody go?
Oh, okay. Carter, you got anything you can show?
Yeah.
All right, let's see what you got, sir. You should be able to just start. There you go. All right, dude. Yeah, see, you edited pretty good, man. That's very good. You cross things out. All right, so Lee, all you got to do is finish off that second problem and use the same skills. That don't make sure you change the values and everything to do it right, and turn it in. Okay. So I'll see you later. Who's next? I got not Richardson. She said come back to her. Stevenson, you there? Can you share your screen so we can see how much work you got done? Mr. Stevenson, are you there? I have to come back to him. All right, Melody, how about you? What do you have so far? What did you work on?
Is I'm sharing, am I sharing it?
Yeah, you're sharing now, Mel. Yep. Okay. All right. Where's your dot? Oh, okay. Okay, you putting it together. You just gotta make sure you cross out the right stuff, Mel. Okay. So that's cool. Who's let? Melody, you can go if you have no more questions. But turn it in by 8, both parts. So Stevenson, are you back? I see some shadows, but do you have anything typed up, sir? I see his head now a little bit. Okay, so
Hold on, typing.
Are you trying to share your screen?
What's your email?
My email? Why are you using my email? You just share the screen.
Let's see.
You hit the share button on Google Meet. And then take me to your document. See how much you got typed up. You having trouble with it?
Hold on, I'm trying to present now.
Oh, okay. I was like, I think you know how to do it. I think I've seen you do it before.
I'm sharing it, but
There you go. I see you. Okay, now where's your document? Oh, there's your document.
I was still typing.
You still typing stuff up. So where's your other document where you had the work in there? You just had it on the screen there. I seen you had a lot of stuff.
I don't know where is this go.
Did you close it by accident? It should still be in your Google Docs if you. I don't know what you named it though. That's November 10th. No. Okay, so you guys got to find what you was working on, and you know how to submit it, right, to ESB?
Yeah, I know that's.
Right. So you just want. Right, that's my screen. So you got to still get all these notes and probably watch the video. Um, Also, I'm going to be putting the chat transcripts on ESB so you guys can go back and look at the notes. All right. But try to get some more that's typed in there. Richardson, are you ready? You can stop sharing, Stevenson. You got your class point.
Yeah, I'm ready, but I gotta cross the stuff out, Mr. Tyler. I just put it in the chat.
That's fine. I just wanted to see how much you guys started. So, Stevenson, you can stop sharing so I can see hers. Okay, and he left too. All right, well, he probably needs a break. So we're just waiting on you to see if I can get your points, Miss Stevenson. I'm sorry, Richardson. There you go. Okay, you show me your document. There you go. You got the hang of it. Yeah. Okay. Scroll down a little bit. Okay, so you got most of the notes. You just got to clean it up, right? Okay, so just don't forget that homework problem and turn everything in by 8. You do know how to put it in EDSB, right?
I know how to put it in.
Okay, so it's due by 8, and I'll see you later.
Okay, see you.